Alright, hi everyone. So finally we are in the last topic of our Pure Max tree, so which is topic 9, complex numbers. So if you are referring to your textbook, then it will be chapter 11. Alright, so as usual, we'll start with the learning outcome first. So as you can see, the learning outcome of today is actually quite long. So yeah, I'm not going to read through everything here, but to let you to have a very brief idea on what is this lesson about. So yeah, today is going to be like a introductory lesson on what is that meant by complex number. So what is a complex number? Then you will be introduced some new terms. For example, what is a real part? What is the imaginary part? And also what is the conjugate? And also how do we say that two of the complex number are equal? Okay, so the part on the modulus, the argument, and also some angles involved here, we are going to do that in next lesson. All right, so yeah, that's the first thing. Then the second one is after you have an brief idea on what complex number is, then we'll proceed with carry out some simple operation, like for example addition, subtraction, multiplication, and division, like for the terms that involve two complex numbers. Okay, so basically this is like the whole idea of today's session. All right, so let's start with our introduction. Okay, so before we move on to the part where we talk about the complex number, I would like to take some time to go through with you like the number system in mathematics. So I'm not sure whether you learned this in IGCSE, but I guess that it will help you to have a better understanding on what is the role or what is the position of the complex number in like this whole system. Okay, so far in the maths that we have learned, right? So all the numbers that we have been dealing with are all called as the real numbers. So I'm going to explain the whole system by using the diagram below. All right, so can you try to recall what is the first number that you have ever learned in your life? So what is the first thing that you learn in terms of like what we call as like mathematics in your life? So normally when we were young, right, then the thing that our parents used to teach us to do is like to do counting, right? For example, like you have one pen, two pen, three pen, and so on. Then that's the first thing that we know about maths. Okay, so all the numbers that we actually use to do counting are called as natural number in maths. So it's denoted by the symbol of n, and the smallest natural number that we have is 1. So 1, 2, 3, 4. So which means all the number that we use to do counting are all called as natural number. Okay, then maybe when you go to kindergarten and you know that, yeah, there's one number that actually means nothing, which is 0. Okay, so natural number plus 0 actually form another kind of number, which is called as the whole number. So whole number is denoted as W. All right. Okay, then when you move on to higher level, then you know that except besides the positive number, then we also have like the negative number, which is called like -3, -1, -100, and so on. Okay, so all the negative numbers plus the whole number and the natural number actually made up integers. Okay, and it's denoted by Z. All right. Okay, then after that, we know that numbers also can be expressed in the terms of ratio. So that's why we have like the fraction, for example, like 3 over 5. Okay, then it also can be expressed in the form of decimal. So for example, like 1.375. Okay, or even we can have like mixed number 1 and 1 over 3. So 1 and 1 over 3 can be represented in like decimal, which like 1.33, and it's like infinite, right? So it's like this. Okay, and of course you have negative as well, like for example -5.5. So all this number, including all the integers, are called as the rational number. Okay, so all this number will be denoted by the symbol Q. All right. Okay, so outside of this, right, so we have what we call it as the irrational number. So irrational number, when you look at the words here, right, you can see rational, so it's like ratio. Then you have like irrational, it's like the one that you can't express it in terms of ratio, which means you cannot express the numbers in the form of fraction. then it's all falls under irrational number. So for example, square root 2. So for example, like pi, for example, like e, for example, like square root 5. Okay, so all this irrational number is denoted as like q bar. So sometimes they use p as well, then sometimes, yeah, they use like q star as well. So yeah, basically the bar and the star here actually means the conjugate, meaning like the opposite of the rational. So rational is q, so that's why irrational is like q bar or the q star, or sometimes they use the word p. Okay, but it's quite rare lah. Yeah. Okay, all the type of number here, right, actually made up what we call it as the real number. Okay, and the real number is denoted as R. So which means real numbers consisted of all the rational number and all the irrational number. So this is the type of number that we always been working in our mathematics so far. Okay, so for today's lesson, we are going to look at what is outside of the real number. So which today we are going to I'm going to introduce you like two ideas here. So the first one is what we call as the imaginary number. So imaginary number is like something that normally we'll say that it's like no solution or it's something that we cannot solve. So imaginary number is denoted as I. Okay, so normally you will have something like I, then negative 2i, even like square root 7i or like pi I. Okay, so you'll be able to understand it later in a much more detailed way. So which means I is like a symbol, it's actually a letter that we use to describe some type of number. Okay, then after that, after we learn imaginary number, then we'll move on to the next level, which is what we call as the topic of the lesson today, which is the complex number. So complex number is actually a number that made up of both real number and also imaginary number. So you will have the form like, for example, normally it will be denoted as x plus yi. Okay, so this is the two thing that we are going to look at today. Okay, so I hope that you can like see the whole picture. So now let's try to look at what is that actually represented by the imaginary number here. Okay, so let's start with imaginary numbers. All right, so no worry, when you look at the topic, you like it's called as like complex number, so it seems to be like a very complicated idea, yeah. But actually for this first lesson, it's going to be like quite easy because it's just like an introduction. So perhaps you'll find it a little bit difficult at first because like this is the first time that you heard of this idea. But then after you understand how the whole thing works, then it will be quite easy. Yeah, because the harder one is going to be like next the next or like the next lesson. Yeah, so for the starting wise, it's going to be like quite easy to pick up. Okay, so in a set of imaginary number, we introduce a new member which is called as I. So what does that mean by I? The definition is given I squared is equal to negative 1. So it means that when I try to solve for I, right, I'll be able to get I is equal to square root negative 1. Okay, so what is this actually mean? Because you'll feel like a square root negative 1 is something that you cannot solve, right? So yeah, basically this is something that we are going to deal with today. Okay, so I'm going to explain this idea by using these two situations here. Okay, consider the equation of x squared plus 1 equals to 0. Alright, so let's try to solve it by using the normal approach that we used to do. So we have x squared equal to negative 1, right? So by looking at this, then you know that x will be equal to positive and negative square root negative 1. So we know that we cannot solve a square root with a negative number. So that's why we'll have a conclusion that you have no solution, right? This is normally how we do. Because what we are trying to do is we try to find the solution in the set of real numbers. Okay, but today we are going to find a solution for this. Alright, so which means that when I try to solve x squared equal to negative 1, and I know that x equal to positive negative square root 1. So do you remember what is square root negative 1? It's actually I. So which means my answer is positive negative I. So actually I have solution and I have two solution, which the first one is going to be negative I, then the second one is going to be positive I. Okay, so that's the idea. So this imaginary number I is called as the unit imaginary number. Unit imaginary number. Okay, as this number has a coefficient of 1, so which means like the negative 1 lah. So all the other imaginary number are going to be the multiples of I. Okay, so that's why they are always in a form of either sometimes they it depends on whether you like to use A and B or X and Y lah, but for me they actually just mean the same. So either they will write in BI or they will write like IY. Okay, but basically they just going to be the exactly same thing. Yeah, okay, so let me we'll try to go through like this example number 1, then you'll be able to understand what is that mean by like the multiples of I. Okay, so yeah, we know that like when you look at all this number here, right, it's basically not something that we can solve as usual, lah, right? So but now we are going to solve all this. Okay, and you can't use calculator to help you to solve this. Okay, so A. So which means we need to write all these number in their simplest form. So let's start with square root negative 9. So we are going to use the law that we use in CERT to actually help us to solve this. So which means negative 9 is actually the same thing when we try to write 9 then multiply by negative 1, correct? So when we try to split it into 2, so I will have square root 9 and then multiply by square root negative 1. So square root 9 will give me 3. So square root negative 1 is actually I. So that's why square root negative 9 is, square root negative 9 is actually 3I. Okay, as simple as that. So let's look at B. So square root negative 5. Okay, so same thing, which means that negative 5, we can express it at 5 times negative 1. So which means I can split them into 2. So square root 5 multiply square root negative 1. So square root 5 is not something that I can solve, right? So square root 5. So square root negative 1 is I. So that's why my answer is square root 5I. Okay, so move on to C. So square root negative 18. So when I try to do this, then I'll check whether I can try to simplify 18 or not. So I can use 9 times 2, right? So which means that for me to get this, then it's going to be 9 times 2 and then times negative 1. Okay, so I have square root 9 multiply square root 2 multiply square root negative 1. So when I try to solve that, I'll have 3 square root 2 and I. Okay, yeah, so this is actually what is that mean by the multiples of I. So I is like the basic unit, the unique imaginary number that you have. So any other imaginary number that you want to form is going to be like the multiples of I, just as simple as that. Okay, so move on to number 2. Okay, so I guess this should be easy. So x squared equal to negative 25. So which means x is equal to positive negative square root negative 25. So same thing, we can try to express it like in 2. So it's going to be like 25 multiply negative 1. So which means my last answer will be positive negative 5i. Okay, so yeah, let's move on to B. So we have 4x squared plus 484 equals to 0. Yeah, so if you are confident enough, then yeah, you can actually try it by yourself. Then after that, check your answer. So same thing, divide by 4. So x squared will be equal to negative 121. So when I try to bring this over, okay, then I'll be able to solve it. So if let's say you are not familiar yet, so yeah, it will be good that you just write down this step before you actually transform it to I. So positive negative 11i. Okay, so don't forget about the positive negative. It's the same thing like how you solve a square root. Okay, so C, x squared plus 20 equals to 0. So which means x equal to x squared equal to negative 20. Alright, so x will be equal to, we can straight positive, negative, okay, 20. So it will be equal to plus minus, so we can try to have 4, yeah, 5, and then negative 1. Okay, so which means my last answer I'll have positive, negative 2, square root 5, and I. Alright, so yeah, I hope that you shouldn't have any problem by just applying your I inside here. Okay, so 3. So we are going to go through like all this side in the indices form for our imaginary number. Yeah. Okay, so let's start with the I cube. Okay, so how are we going to solve this? Any idea? So just now the definition actually tells us that I is equal to square root negative 1, right? Then we know that I square is actually equal to negative 1. So what we can try to do here is we try to split it as square and then you multiply by 1, correct? So what is I square? I square is square root negative 1. Sorry, I square is negative 1, right? So which means it's going to be negative 1 multiplied by I. So what do I get? Then I get negative I. Okay, so let's move on to B. So same thing. So I power 4. So which means I can always put it in I square multiply I square. So I'll get negative 1, then multiply with negative 1. So what's my answer? It's going to be 1. So it's the same thing if let's say you want to do I square then in the bracket square, then you're going to get negative 1 square lah, which means it's the same thing. Yeah, so what I say is like you can always do like this as well. So which means I4 is equal to I square then square. Okay, so since I square is negative 1, so which means negative 1 square, you are just going to get 1, which is the exactly same thing. Okay, so let's move on to C. So I negative 6. So let's try to change it first. So I have negative 6, right? So which means it will become 1 over I power 6. So how do I solve the I power 6? So I can always put it in like 1 over then I square cube, right? So I square will give me negative 1, right? So 1 over negative 1 cube. Okay, so negative 1 cube give me negative 1, so that's why my answer will be negative 1. Okay, so move on to D. Yeah, so the question is negative 1 and power 6. Sorry, negative I and then power 6. Okay, I think this is going to be easy. So you can try to think of when you have any number that is negative, right? After you put into the power of an even number, the negative will be eliminated, right? Like for example, negative 1 to any power of even number, then it will give you like 1 as the answer. So that's why negative I bracket to the power of 6 is just exactly the same when I try to do I power 6. Okay, so that's why I square then cube as well. So negative 1 cube, it will just give me the answer of negative 1. Okay, so move on to E. So 2I and then power 5. Okay, so we're just going to do the same thing like how we solve an indices. So 2 power 5 as well, then 1 power, I power 5. So 2 power 5, then I have 32. So 1 to power 5, how are you going to solve this? Yeah, so you can just treat it like square, I square, then multiply by I. Yeah, so you can imagine like I square, then it will be multiply negative 1, multiply negative 1, and then multiply by the last I there, right? So here we'll give you 1, then after that 32I. Okay, so that's it. Then after that, let's try to look at F. Okay, so 3, yeah, this is going to be like a little bit plus and minus here and there. So we have 3I square plus 3I bracket square. Okay, so when we try to solve this, then perhaps we can start from here. So 3I square, there's nothing that we can continue to do here, right? I mean, you can try to change I square lah, but we can do it later. So 3 square, it will give me 9, then I square, then it will give me I square as well. So when I plus them together, then I'll be able to get 12I square. Okay, so from here, then I'll be able to continue. And then I square is actually negative 1, right? So that's why it will give me negative 12. Okay, so G, negative 9i plus negative 4i power 3. So same thing, let's try to solve the bracket first. So plus, so negative 4 to the power of 3, then I will have negative 64, right? Then I also need to power 3, so I power 3. All right, so negative 9i, so I have minus 64, right? So what I can try to do is split this into 2, so which I have I squared multiply with I. Okay, seems like a bit, yeah, so let me try to write like this. Okay, so I'll have negative 9i minus 64. So when I multiply I powers, I squared, then it's actually negative 1, right? Then multiplied by I. So I have negative 9i minus 64i, which will give me my last answer, which is plus 64, right? So that's why 55 positive 55i. All right, so move on to H. So 9i plus 16i, then divided by 4i. Yeah, I guess this is quite easy. So let's try to solve what is inside first. So we have 9i plus 16i, which will give us 25i over 4i, right? So you might have a question, can I cancel off the I? Yes, you can, because it's the same thing. If let's say you try to write like 25 square root negative 1, then 4 square root negative 1, then isn't it you can actually cancel this? So it's the same thing, we can actually cancel the I as well. So 25 over 4. So square root 25 over 4 will give us 5 over 2, and make sure you have positive and negative. Okay, so let's move on to I. So I is 2i6, right, power negative 3. Okay, so we can try to solve it. So yeah, you can just multiply inside first. So which means I have 2 negative 3 and then I negative 18. All right, so when I try to write it in a form of fraction, then it will give me like 1 over 2 power 3 is 8. So 8 then I 18. So we can try to solve the I 18. So which means it will be 8. Then after that, it's going to be I squared then power 9. Right? Because 2 times 9, it gives you 18. So that's why now we try to substitute 1 over 8, then I squared is going to be negative 1 power 9. So that's why it will give us negative 1. So that's why your answer is negative 1 over 8. Okay, so that's the part for imaginary number. I guess it's actually quite easy. Alright, so now we'll move on to the part where we talk about the complex number. Okay, so if you can recall from the number system that we did in the introduction, right, you can remember that complex number is a combination of the real number and the imaginary number. Okay, so that's why a complex number is actually a number that defined as a number of the form of x plus I y. Okay, so it's the same thing. Maybe sometimes they use a plus bi. They just mean the same thing, like it's just they are using x, y, or ab only. Okay, where x and y are the real numbers and I is the unit imaginary number. Unit imaginary number. Okay, so normally the complex number will be denoted as z. So z equals to x plus iy. So we have the first part, which is consisted of the real number part. So it's called as the real part. So in short, we will try to call it as real. So re then z. Okay, and then for the part for the y, right, the y is actually the multiple of I. So the real number y is the imaginary part for z. Okay, imaginary part. So this part will be denoted as I am z. Okay, so this is like the symbol that you saw just now in the learning objective. So basically the first part is the real part, then the second part is going to be the imaginary part, just like that. Okay, so you can imagine when, if let's say the x is 0, right, then what happened to your z? So if x is 0, then you will have z equal to iy only, right? So when you look at this one, right, actually what number is this? It's going to be a imaginary number. So you go back to the imaginary number session that we did just now, if the x is 0. Okay, so if the y is 0, meaning that you will have x equals to z equals to x. So x is the real number part, right? So that's why z will become a real number. Okay, so yeah, basically complex number is just a combination of real number and the imaginary number lah. So if let's say the real part is 0, so that's why the number become imaginary. If let's say the imaginary part is 0, then the number become real, just like that. Okay, so for equal complex number, two complex numbers are equal if and only if their real parts are equal and also their imaginary numbers are equal. Okay, so for example, I put in an example here. So if let's say we have the first complex number equals to a plus bi and the second complex number is x plus yi, if we say that the two complex number are the same, so which means that x must be equal to, a must be equal to x and then b must be equal to y, then only we can say that the number complex are equal to each other. Okay, so I guess this is quite easy. Is going to be a little bit similar to like your vector. So as the x part and the y part must be the same, then only you can say that it's the same. It's the same similar idea. Okay, so for the conjugate for complex number, okay, so yeah, maybe you do not know what is the words meant by conjugate, but I believe that you actually learn this when you learn cert in your IGCSE. So yeah, like for example, if let's say you have something that is 1 over 1, 2 minus square root 2. So if let's say you want to simplify this, then what you will try to do is you will multiply the whole thing by this, right? Yeah, so what you will try to do is you will change the symbol in the middle here from positive to negative or from negative to positive. So to make your answer like become a simplified version. So conjugate is just an idea of that. So the complex conjugate for z equals to x plus iy is actually defined as z. So the symbol for conjugate is like z star. Okay, or sometimes they try to use z bar as well, but in your syllabus they try to use this, so we will just follow and do the star. So it will be equal to x minus iy. So basically just changing the symbol in between. Okay, or sometimes, sorry, I should write here the z bar, or sometimes it's also written as z bar. Okay, so for example, if let's say you have a z which is 1 plus I, which means that its conjugate is going to be 1 minus I. Okay, so if let's say you have z equals to negative 3 minus 4i, then the conjugate is going to be negative 3 and then plus 4i. So remember, we are just going to change the symbol in the middle. Okay, so later we'll see after. So normally it's the same thing like when we try to do this, right? Then the idea is for us to get rid of to having a cert in our denominator. So when we try to multiply by the conjugate, and we will be able to apply this concept when we try to do division later. So it's the same idea that we try to prevent that we have a complex number in our denominator. Okay, so that's the idea of using the conjugate. Okay, so now we'll try to look at like the simple operation by using two complex numbers. So we are going to look at the addition, the subtraction, the multiplication, and also the division. Okay, so the processes that we use to calculate complex numbers are actually the same when we try to calculate like the expressions involved cert. So that's why you have the conjugate just now. Alright, so for example, if let's say the first complex number is given 2 plus 3i and the second one is 8 minus I. So when we try to do addition and subtraction, it's just the same thing. We just collect the same terms, then we try to do the addition and the subtraction needed. Okay, so if let's say we are going to do z1 plus z2, okay, So when I try to solve it, then I will have 2 plus 3i plus 8 minus I. Okay, so we need to put the same term together lah. So number and real part and the real part. So which means it's going to be 2 plus 8. Okay, then after that, the imaginary part and the imaginary part. So that's why then I'll get my answer 10 plus 2i. Okay, so the same thing when we try to do subtraction also, we try to collect the same terms as well. So 2 plus 3i minus 8 minus I. Yeah, so which means 8 will need to minus the 8, 2 minus 8, and then plus 3i, the imaginary number, plus I. Alright, so what do I get? Then I will have negative 6 plus 4i. Yeah, I guess this is quite simple. Okay, so move on to multiplication. So if let's say we are doing multiplication for the two complex number just now, so z1 multiply z2. Okay, so I'll have 2 plus 3i and then multiply with 8 minus I. So I will just going to expand it as usual, then simplify by using the I square equals to -1 definition. Okay, so equal to, so when I try to expand, then I'll have 16 minus 2i plus 24i and then minus 3i squared. So, okay, I hope that you're following. 2 times 8, 2 times -1, 3i times 8, 3i times -I. Okay, so I can combine these two together. So I'll get plus 22i. So I squared is going to give me -1. So that's why here I got plus 3. So when I try to combine with 16, then I get 19 plus 22i. Okay, so if let's say we try to multiply with its conjugate and let's try to see what happened. Okay, so let's try to use z1, I guess. Okay, so we use z1 then multiply by the z1 conjugate. So which means we have 2 plus 3i. So its conjugate is going to be 2 minus 3i, right? So let's see what happened when we try to expand. So we have 4 minus 6i plus 6i minus 9i squared. So you see, -6i plus 6i is going to eliminate each other. So that's why I left with 4 minus 9, -1. So I'll have my answer 13. So it becomes like a real number now. Yeah, so when you try to multiply the complex number with its conjugate, then you'll be able to get a real number. Okay, so let's move on to division. Okay, so same thing. We try to use z2 divide by z1. So here we have 8 minus I over 2 plus 3i. So you'll realize actually there's nothing that you can try to do. It's actually like same thing like if let's say you have 1 over 4, then you do not have anything to do, right? But the idea is we try to we will try to express this fraction without having a complex number in the denominator. So it's just like the same thing like how you solve a third expression in terms of division as well. So we will try to multiply by the fraction formed by its conjugate. So meaning 2 minus 3i and then 2 minus 3i. Okay, so yeah, we'll try to simplify it like this. So let's try to expand it. So 16 minus 24i. Alright, then minus 2i and then plus 3i squared. So over, so 2, then 4. Yeah, so it's exactly same thing like what we did for the multiplication lah. So let's try to repeat it again. So minus 9i squared. Okay, so it will be equal to, so combine the -24 and -2. So I got -26i and then plus 3, -1 is I squared is -1. Then after that 4 minus 9, so another I squared -1. Okay, so 16 minus 3, then I'll be able to get 13 minus 26i over 4 plus 9, so it's 13. Okay, so we can try to simplify this. So 13 over 13, we have 1. So 26 over 13, so we have minus 2i. So that will be our answer. Alright, so yeah, that's the introduction part for how the basic operation look like for the complex number. Okay, So yeah, that's almost the end for the notes, and we are just trying to go through the few example that we have here, and that's the end for this lesson. Okay, so number 4, solve the equation of 5z squared plus 14z plus 13 equals to 0. Okay, so this is the exactly same thing like how we solve a quadratic equation. So it's just that this might be a question that when you try to check the b squared minus 4ac, right, then you should be able to realize that you have 14 squared minus 4 times 5 times 13. Okay, so from here, then you'll be able to see like 14 square, that's going to give you 196, then minus 20 times 13, so 260. So it's going to give you a negative number which is lesser than 0. So this is the idea of, that there's no real roots. But now we are going to solve it by using the complex number, by express them in a form of a complex number. Okay, so it's the same thing, so which means that by using this, then you can use your calculator to check first or so on, but we are just going to use the equation to help us to solve this. So that's why z will be equal to negative b plus minus b squared minus 4ac. Yeah, because this is a quadratic equation, right, over 2a. So let's try to substitute the number. So negative 14 plus minus b square minus 4ac. All right, and then divide by 2a, so which is 2, and then 5. Okay, so when we try to solve, then we will be able to get negative 14 plus minus square root negative 64, so over 10. So we know that square root negative 64 is going to be 64 multiplied negative 1, right? So that's why it will give us negative 14 plus minus 8i, okay, over 10. Then after that, we can try to simplify. So divide by 2, divide by 2 for everything. So I'll have negative 7 plus minus 4i over 5. And that will be my answer. So let us try to simplify it. So I'll have two answers. The first one is going to be negative 7 over 5 plus 4 over 5i. Then the second one is going to be negative 7 over 5 minus 4 over 5i. Okay, so let me try to show you the calculator. Okay, so just want to show you that if you are using your Casio ES, right, I think some of the equation you will be able to check it by using your calculator. So I already tried to input everything beforehand, so you'll be able to see that you can actually get the answer in terms of complex number. So you see this is like our first answer, then this is our second answer. But if you are using Casio MS, I don't think the calculator can help you to do so. Yeah, because the calculator will show you that you do not have any real value for this equation. Yeah, but don't worry about it. What I mean is that you can use your calculator to check for your exercise for this one, but this type of question wouldn't like come out in your exam because it's going to be like much more advanced than this, because this is like a introduction lesson only. Yeah, so this is like an idea for you to understand why do we need complex number, then how we try to apply complex number. Yeah. Okay, so let's try to go to number 2. Okay, number 5 is similar with number 4, but we'll try to do this by using the other method, which by doing our completing the square. Okay, so it's going to be the exactly same thing like how we normally do completing the square in solving quadratic equation. So minus z will equal to negative 3. All right, so yeah, let's try to factorize first. So take out the 2, so z squared minus 1 over 2z equal to negative 3. Okay, so now we can carry out the completing the square. So I'll have z minus 1 over 4 square minus 1 over 4 square, okay, equals to negative 3. So now let's try to expand it. So I'll straight away bring this one to the other side, so equal to negative 3, and then plus 2 multiply 1 over 4 square. Okay, so from here, then I have this one, just copy first. let's try to solve the right hand side. So equal to, so when you try to solve this, then I will have 4, 8, so negative 23 over 8. Okay, so move the 2 over, then I will have z minus 1 over 4 square equal to negative 23 over 16. Okay, so you can see I have this negative number, so that's why when you try to when you try to square root the answer, then you know that obviously you are going to have a complex number already. So square root negative 23 over 16. Okay, so now we can try to move the 1 over 4 to the other side. So z equal to 1 over 4 plus minus. So let's try to simplify this. So 23 is a thing that we can't square root, but 16 we can, right? So that's why I have 23i, then over square root 16 give us 4. Okay, so from here, then I'll be able to get my answer. The first one is 1 over 4 plus square root 23 over 4i. Then I have the second one is 1 over 4 minus square root 23 over 4i. Okay, so I'm not sure you realize or not, right? This is something that when you try to look at number 4, you can always see this trend. So meaning that if let's say we have a quadratic equation which its solution is not going to be a real roots, right? It's going to give us the complex number. Normally your answer for your roots, right? It will be the conjugate of each other. So which means you can see that negative 7 over 5 plus 4 over 5i, then your the other root is going to be the conjugate for your first root. You can see, right, the plus become minus here. So same thing for number 5 as well. So you can see that this one is going to be negative, then this one is going to be positive, and this one is a conjugate for this one as well. Okay, so that's why it's going to be the same thing for every time for all the normal quadratic equation that you have that gives you a complex number. Because when you try to look at the equation, right, then you'll be able to expect that already, because this number and this number is going to be the same. So what is different is just that 1 plus and 1 minus, right? So when you try to solve, and at the end of the day, you'll be able to get like the roots will be the conjugate of each other or the other way around. Yeah. Okay. So remember these properties, and we'll be able to use this when we try to solve number 7 later. Okay, so now let's try to look at number 6. Okay, number 6. So this is a pretty easy questions. Yeah, so given that 2x plus y plus y minus 5 is equal to 0. So what you can see that is that there is a real part, then there is an imaginary part. So after you, the complex number is going to be 0. What is that mean? It actually means that the real part is going to be 0 and the complex part is going to be 0 as well. So at the end of the day, you are still getting 0, right? So that's why it's just like solving simultaneous equation. So we have 2x plus y. Okay, the real part should be equal to the real part, which is 0. So that's why the imaginary part is going to be the same with the imaginary part, which is 0 as well. So we can solve for our y, which gives us 5. So after that, we try to substitute back here. So 2x plus 5 equals to 0. So that's why x equal to negative 5 over 2. Okay, so just like that. Alright, so move on to 7. Okay, 7. One root of the quadratic equation x squared plus px plus q equals to 0 is 2 minus 3i. Find the values of p and q. Yeah, so this is a question that I mentioned just now. So yeah, you remember, so I said that normally for the root for your quadratic equation, it will be the conjugate of each other. Okay, so it means that, okay, maybe in this question, we try to let the roots be alpha and beta. Okay, so which means that if let's say my alpha is given 2 minus 3i, so which means that my beta is going to be the conjugate of my alpha, which is 2 plus 3i. So after I get this, then I can use like the properties of roots that I learned in quadratic equation to solve this. So which means we know that the forming of the quadratic equation is going to be x squared and then minus alpha plus beta x and then plus alpha multiply beta, right? This is what we learned in P1. I hope that you still remember. So by using this, then we'll be able to use the information given, then substitute. So alpha plus beta is going to be equal to minus 3i and then plus 2 plus 3i. Okay, x. So plus alpha multiply beta, so 2 minus 3i. Of course, you can try to find alpha plus beta and alpha beta first, then only write your answer. So it's just going to be the same thing. It's just like which one you prefer. Okay, so 2 plus 3i equals to 0. So now we try to simplify it. So x squared will be minus x squared minus, so 4. And then, yeah, I got no I anymore. So x plus, so I need to expand this. So I'll get 4 and then minus 9i squared. Okay, so I squared is actually negative 1. So that's why from here, then I'll be able to get 4x then plus 4 minus 9 then negative 1. Okay, so I can continue to simplify. So x squared minus 4x plus 13 equals to 0. Alright, so from here, then I can get my answer. My P is actually equal to negative 4 and my Q will be equal to 13. Okay, so just like that. Another alternative that you can try to do is you can try to do this as well. The x minus alpha, then x minus beta equals to 0. Then you substitute your alpha and beta inside, then you try to expand it. You're going to get the exact same answer. Yeah, you can try it out as well. Okay, so move on to the last question. Okay, last example. Find the values of the real number p such that p plus 2 minus 3i, 1 plus 5i is an imaginary number. Okay, so yeah, from the notes just now, we know that like the complex number is a combination of real number and imaginary number. So if let's say you have x plus iy, right? So if let's say this expression going to be a completely imaginary number, so which means that the part for the real part is going to be 0, then only it can be a imaginary number. Okay, so that's the idea. So that's why before we proceed, then we might need to expand this first. So p plus 2 minus 3i, 1 plus 5i. So let us try to expand it. So we have p plus 2 plus 10i minus 3i minus 15i squared. So we got p plus 2 plus 7i minus 15 times negative 1. So from here, then I'll be able to get p, then 2 plus 15, then I have plus 17 plus 7i. Okay, so if let's say it's an imaginary number, right? So imaginary number, so which means that the real part is going to be 0, the RE. So if let's say this is Z lah, the REZ has to be 0. Okay, so which means in this part, then which is the real part is going to be P plus 17, right? So that's why P plus 17 must be equal to 0. So from here, then I can get P is equal to negative 17. Alright, okay, so move on to B. So find the values of the real number x and y such that the left hand side is equal to the right hand side. Yeah, so which means when we try to compare, it's also the same thing, which means the real part and the real part must be equal to each other. Then the imaginary part and the imaginary part must be same as each other. So for that, let's try to copy the question first. Minus 3ix minus 5. Okay, then the next one, we can try to expand it first because we need to split it into the form of like real part and imaginary part. So it will be good that we can expand it. So plus 4yi equal to negative 2y minus 3xi minus 15 minus 10i. Okay, so now I can try to arrange them. So for the left hand side is fine already. But for right hand side, which means that I might want to write my negative 15 in front because this is the real part. Okay, then the part with I, then I'll try to put them together. Okay, so which means if the left hand side and the right hand side is the same, which means the real part must be the same, which I will have my first equation, which is 4x equal to negative 2y minus 15. Okay, so this is my first equation. Then I will have my second one is going to be 4y equal to negative 3x minus 10. Okay, and this is going to be my second equation. So now we need to solve this simultaneous equation so that we can get our answer. Yeah, so it depends on you like how you want to multiply and so on. So I will try to do it by 4y. Yeah, okay, so I'll try to change number 1. Okay, so I have 2y equal to negative 4x minus 15. So when I try to multiply 2, then I can get 4y equal to negative 8x minus 30. Okay, so this will be my third equation, and I'm not going to change anything for 2. So after I get this, then I can use my number 2 equation to minus my number 3 equation. So 4y minus 4y, then I got nothing. So yeah, I got 0 equal to this one minus this one. So I have 5x. So negative 10 minus, so I will have plus 20. So from here, then I can solve and get x equals to negative 4. Okay, so move on, same thing. Yeah, depends on you which one you want to use. I'm going to just use 2. So 4y equal to negative 2, negative 4 minus 10. So I have 20. So 12 minus 10 for y. So y will be equal to 1 over 2. Okay, so that's why my answer will be x is equal to negative 4 and y equals to negative 1, and the left hand side, the complex number for left hand side is the same with the complex number in the right hand side. Okay, that's it for this question. Alright, so spend some time to do your homework and so on. If you have any question, then please just approach me personally in chat. Okay, alright, so that's it for today's session. Thank you.